everybody, this is Miss Moran. We are here with Unit 2, Video 1, defining a radian and converting between radians and degrees in both directions. So we'll start here with defining a radian. Since we've not really used that term before, radian is actually a way to measure an angle. Similar to measuring an angle in degrees, just like you'd measure length in inches or meters or feet. We can measure an angle in two different units. So radian is one of them. So I'm going to go ahead and draw for you this definition to help explain it. A radian, the measure of 1 radian will be according to this. You're going to have an angle with its vertex at the center of the circle, and this angle will intercept an arc on that circle. The arc's length is equal to the radius. If that's true, then the measure of angle theta equals 1 radian. So only if the radius is equal to the measure of the arc that the angle is intercepting. So I'm going to draw another picture on top of here. Let's grab a purple. And if I draw another angle larger, so I've got this angle, and I'm going to call that angle alpha. The arc that alpha intercepts is much larger than the radius. This length is longer than our radius. Therefore, alpha must be greater than 1 radian. Now, I don't know how big it is because I don't know the ratio of r to the new arc, but I do know that this arc is greater than the radius. So here we have the definition of a radian. So we're going to practice now converting between radians and degrees in both directions. And we're going to start by discussing, since we're talking about an arc length and comparing that to the radius, I'm going to talk about circumference. The circumference of a circle is 2 pi r, so it's dependent on the radius. If the radius is larger, the circumference is larger. Okay, so sorry about the message. 2 pi r would be our circumference. Again, dependent on how large the radius is to determine how large or how long the circumference is. So what we can say is that it takes 2 pi radians to complete a circle, or 360 degrees to complete a circle. Therefore, we have 2 pi radians equal to 360 degrees. Notice how I'm using the label radians and the label degrees. I would never say that 4 cups is equal to, I would say 4 cups is equal to a quart. I would never say 4 is equal to 1. I would have to include the units to make sure that that was clear. So I will do so here. 360 degrees is equal to 2 pi radians. We can simplify that to say, well, if 360 degrees is 2 pi radians, then halfway is just pi radians. And I can continue to simplify that, and I can say that 1 degree is equal to pi divided by 180 radians. And if I want to go the other direction, okay, then I would say that 180 divided by pi is equal to 1 radian. All right, we're going to use these two right here as our converting factors, so keep those in mind as we go on to the next couple screens here. So I've got 45 degrees, and I'd like to convert 45 degrees to radians. So to do that, I'm going to say, well, 45 degrees times pi divided by 180. Now what this is going to do is, if this was degrees, I would cancel my degrees and I'd be left in radians, which is what we want. So this is going to be pi over 4, or 1/4 pi radians. Let's try it with 600. So I'm going to take 600 degrees times pi over 180 degrees. And I'll notice that my zeros will cancel. And then I'm left with 60 over 18. And I know that they're both divisible by 6. So if I divide the top by 6, I get 10 pi. If I divide 18 by 6, I get 3. So I'm left with 10 pi over 3, or 10/3 pi radian. Oops, ran out of room. So go ahead and try that with number 3, 200 degrees, and number 4, 135 degrees. Here's a good place where you might want to pause until you go ahead and try those. And I'm going to wait a few seconds and then go ahead and give you the answers. But pause now so you can try on your own. Okay, so the answer for number 3 is 10 over 9 pi radians, and number 4 is 3/4 pi radians. All right, now we're going to work backwards here. So what I want to do is I want the pi's to cancel, because when we measure in degrees, we don't include pi. So I'm going to take 2/3 pi times 180 divided by pi. So if it helps you to think that I have the pi in the numerator on my original, and I want to cancel that with the pi that's in the denominator, that'll help you which way to use the converting factor. So the best way I see to do this one might be to either multiply 2 times 180, because that's pretty simple to do in our heads, and then divide by 3, or I might take 180 and divide it by 3 first. You will be doing these without a calculator, so you're going to have to find a strategy that helps you do this without using the calculator. So if I take 360 and I divide it by 3, I know that this is 120 degrees. I'm going to try that with 5/6 pi, so I have 5 pi over 6 times 180 divided by pi. Again, my strategy here is going to be that I want to take 180 and divide it by 6 first, because that'd be easier than multiplying 5 times 180. So when I divide those, I get 30, which I can easily multiply by 5 to 150 degrees. Go ahead now and work on numbers 3 and 4 on your own, and go ahead and pause it, and when you're done you can unpause and we'll check our answers. Alright, so the answer for number 3 is 315 degrees. You can see I did some of my work here by hand. And number 4 is 1800 degrees. Great job.